Hey, what's up? We're talking about dilation. So this is a specific type of transformation. It's going to keep shapes similar, so same shape, proportional, but they're not congruent at this point. Okay, remember, so we're losing the shape of not the shape, we're losing the size of it. So this dilation changes shape. We're going to talk all about that. If you've ever done any kind of design work, then you've done a dilation, right? So I can enlarge this, I can shrink it back down, right? Anytime you change the shape of the original, you created a dilation. And we're going to keep things proportional using what's called a scale factor and look at what this means, okay? So dilations. A dilation is a transformation in which a figure is reduced or enlarged. Okay, so we're either making it smaller, that's what reduced means, or we're making it bigger, which is what enlarged means. And we do this by using a scale factor. And as soon as you see scale factor, you should be thinking multiplication. Okay, to dilate a figure, so we're multiplying, making it bigger or smaller, we multiply by the coordinates, okay, your x, y, of each vertex, lots of vocabulary, right? Those are our corner points, by the scale factor, and we just call it K until we know what that number is, okay? So the rule looks like this. We have X, Y. This is our original or our pre-image points, okay? We've been doing that this whole time. You plot your points, the coordinates are X, Y, okay? But now we're going to transform it into the new image. And that's where we multiply by K. Remember, K is our scale factor. What are we increasing or decreasing by? That's your multiplication number right there, okay? When that number, when the scale factor is larger than 1, so 2, 3, 5, 7, 1.5, okay, that's going to enlarge our shape. Think about recipes. If I double a recipe, I'm making more of it. If I triple a recipe, I'm making more of it, right? So when that number is larger than 1, we are increasing it, okay? When that number is between 0 and 1, that's what all of that means right there. When it's between 0 and 1, the dilation is a reduction. Remember, that means getting smaller. Okay, and think about it, if I took half a recipe, if I did 2/3 of a recipe, I'm making it smaller. I don't want as much, okay? So larger than 1, we're increasing the size. Less than 1, we're reducing the size. Let's look, that's a whole lot of words. Let's look at what this means. Triangle ABC is dilated. Okay, so we're thinking multiplication, increase or decrease. With respect to the origin by a scale factor, all right, that's what we multiply by of something to create the image triangle A prime, B prime, C prime. Okay, this was our prime notation that we talked about. You have to know that that notation tells me this is the new shape, okay, because you have to know which one is the new shape so that you accurately describe the transformation. All right, so let's take all this information. Triangle ABC is right here, ABC. This is the original, okay? And then we have A prime, apostrophe means prime, B prime, C prime. Look, we got larger, right? So I know it's an enlargement. It's getting larger. And if I look over here, enlargement means that that scale factor has to be greater than 1. So I'm already starting to create all these ideas in my head about what I should be expecting. Okay, and let's prove this mathematically. So we have the original coordinates, or the pre-image, right? Pre-image means original. So, and I love graphs because it's super visual. I can see right there. I can already make the list of the new coordinates for our image just by going and reading them, right? So I'm at 6, 2 for A prime. I'm at -2, -2 for B prime. And I'm at 0, 4 for C prime. And our job now as mathematicians is to describe the relationship. That's what we use a rule for, is to describe this. What am I doing to every x, y coordinate to create the new points? And it should be the exact same rule for every point because we have to change everything the same amount. Okay? All right, so this is what a rule looks like. We start with the original. Okay, so this is our pre-image, our original amount. And then we're going to tell ourselves, what are we doing to the coordinates? Well, let's go look. Okay, scale factor means multiplication. So 3 times what gets me to 6? 3 times 2 gets me 6. 1 times 2 gets me to 2. So if I multiply all of these times 2, times 2 times 2, hey, -2, -2. 0 times 2, 2 times 2, there's 0 and 4. So our rule is 2 times the x value, 2 times the y value gets me my new coordinates, okay? That's my new image. That's how I get it. Multiply x and y by 2. That's what a scale factor does. We multiply. Dilations is multiplication. You multiply by the scale factor. All right, let's look at it one more time. Draw a rectangle WXYZ and its image after a dilation. So I'm thinking, okay, this is a multiplication relationship. It's getting larger or it's getting smaller. With a scale factor, A, this is what I multiply by, of 1/2. Okay, so 1/2 scale factor, if the scale factor is less than 1, it's a reduction. Okay, so this is a reduction, so my shape should be getting smaller. Okay, that's because that's less than 1. So I can come right here, the dilation is a reduction because our scale factor is less than 1. All right, so we're going to plot the original points, and then we're going to find our new ones using the scale factor, and we'll make sure that everything matches up with what we already think is happening with the reduction. So W is -2, -2. X is -2, 3. Oh, look, let me label my points. That's going to be really important. Y is 5, 3, and Z is 5, -2. Okay, connect the points. It should be a rectangle because my problem said it's a rectangle. If we didn't end up with one, I know I plotted wrong. Okay, all right, so let's look at how we create the new ones. Remember, dilations we multiply by the scale factor. The scale factor here is 1/2, so we are multiplying every ordered pair by 1/2. Multiplying every one of them because everything has to change the same amount. That's how we keep shapes similar, proportional. Okay, so 1/2 of -2 is -1. Half of -2 is -1. There's W prime, and I'll plot that, W prime. Okay, half of -2 is -1. Half of 3 is 1.5. That's our x prime, so -1 up to 1.5. There's x prime. Half of 5 is 2.5. Half of 3 is 1.5. So I go 2.5 up to 1.5. There's, oh, not z, there's y prime. And then for z, half of 5 is 2.5. Half of -2 is -1. So I go over to 2.5 down to -1. There's actually z prime, right? Connected, it should still be a rectangle. It's smaller, which matched what we said it should be. It's a reduction because the scale factor is less than 1. All right, so our rule then for this, we take the original coordinates, right? Always start with the original. And then we say, what do we do so that we could get the new coordinates that we plotted, right? Well, we just did 1/2 times x values and 1/2 times the y values, and that gave us our new ordered pairs, okay? So we're multiplying x and y by 1/2. So that's dilations. Dilations increase or decrease our size. It's multiplication by the scale factor. Multiplication by the scale factor.